Section 5.8 is on the rational zero theorem. The rational zero theorem says that if p of x is a polynomial function with integral coefficients, that is, the coefficients are integers, not fractions, then every rational zero of the function p of x equals 0 is of the form p divided by q, which is a rational number in simplest form, where p is a factor of the constant term of the polynomial and q is a factor of its leading coefficient. Let's take a look at an example here. List all of the possible rational zeros of f of x equals 3x to the fourth minus x plus 4. First of all, let's identify what p is. P is all of the possible factors of our constant term, which is 4. So the possible factors of 4 are positive or negative 1, positive or negative 2, and positive or negative 4. Q is all of the possible factors of our leading coefficient, which is 3. So Q is positive or negative 1 and positive or negative 3. Now my possible rational zeros are P divided by Q. So I found this is an interesting way to write it. Let's list all of our possible p values on top, and then all of our possible q values on the bottom. Fortunately, there aren't too many here. And now let's just think of that as a fraction. So let's start with the one denominator here. Q is positive or negative 1. So 1 over 1, let me make a list here. So possible rational zeros. One over 1, so that it'd be plus or minus 1. 2 over 1, plus or minus 2. 4 over 1, plus or minus 4. Now let's use 3 as our denominator. 1 over 3, plus or minus 1/3. 2 over 3, plus or minus 2/3. And 4 over 3, plus or minus 4/3. So you can see we have 1, 2, 3, 4, 5, 6 times 2, because they're positive or negative, or 12 possible rational zeros for this function. Now that doesn't say that there could be irrational or complex zeros as well, but we know that if there is a rational zero, it comes out of this pool of numbers here. So to find actual rational zeros, you can test these numbers using synthetic substitution. So let's go ahead and make a list of all of our possible rational zeros. So p over q. So all of my possible factors of 12 are going to go on top. So plus or minus 1, 2, 3, 4, 6, and 12. And on the bottom, fortunately, these are going to be the factors of my leading coefficient, which is 2. Unfortunately, there's only 2 of those. Well, actually 4, but 1 and 2. Okay, now making a list of these, I'm going to have, let me slide this down a little bit here. I'm going to put each of the numbers on the top over 1. So that would be plus or minus 1, 2, 3. Yes, I know this looks a little tedious, but it's actually going to be kind of helpful. Okay, now let's put each of those numbers on top over 2. So plus or minus 1/2. 2 over 2 is 1. I already have that. 3 over 2. And then 4 over 2 is 2. 6 over 2 is 3. 12 over 2 is 6. I already have those. So that's 1, 2, 3, 4, 5, 6, 7, 8 times 2, 16 possible rational zeros. Now, I don't really want to do synthetic substitution 16 times with each one of those. So I'm going to take a little bit of a shortcut, and I'm going to go ahead and graph that function and see what it looks like. So let's pull up our graphing calculator here. And actually, I already put that in here. So there's y equals 2x to the fourth plus 11x cubed plus 26x squared plus 29x plus 12. Okay, let's go ahead and graph that. And I can see from the graph that it crosses the x-axis right here, somewhere between -1 and or -2 and -1, and then it also looks like it definitely crosses the x-axis here at -1. Let me confirm that by looking at my table. So I'm thinking x equals -1 is a 0, and indeed it is, because when x is -1, y is 0. So I know that I have one rational 0 at x equals -1. Let's go back and look at the graph again. And it looks like I have one between -2 and -1. Now going back to our list of possible zeros, it kind of looks like I do have a value that's between -2 and -1, and that would be -3/2. So let's go ahead and check that in the calculator. I'll go to my table, and what if I enter -1.5, -3/2? And yes, indeed, that is also a 0. So I actually have zeros at, so from the graph, it looks like x equals -1 and x equals -3/2 are zeros. Okay, but let me show you how you would confirm that using synthetic substitution. We're going to test that here. So we're going to test this with synthetic substitution. Start with -1, and the coefficients of my function, 2, 11, 26, 29, and 12. Bring down your 2, -2, 9, -9, 17, -17, 12, -12, and my remainder is 0. So yes, indeed that does give me a 0. Let's try it with -3/2. This could get a little messy using fractions, but this one isn't too bad. Let's bring down our 2. It's going to give me a -3, 8, -12, 14, -21, 8, and -12. And indeed, yes, that is also a 0. Now we're going to use this method, kind of a combination of these, for our last example here, where we have to find all of the zeros of a particular function. So that means the rational zeros, any irrational zeros, and any possible complex zeros as well. And our function is f of x equals 4x to the 4th plus 13x cubed minus 8x squared plus 13x minus 12. First thing I'd like to do is find all of my possible rational zeros. So that's going to be, on top of my fraction, all of the factors of my constant term. So plus or minus 1, 2, 3, 4, 6, and 12. You know, I bet there are people that can do this in their head, but I can't. I need to see it actually written out. And now on the bottom, it's going to be all of the factors of my leading coefficient, which is 4, plus or minus 1, 2, and 4. So my possible rational zeros are going to be all of those numbers on top over 1. So 1, 2, 3, 4, 6, and 12. All of those numbers on top over 2. So 1 over 2 is going to give me a 1/2. 2 over 2 I already have. 3 over 2. 4 over 2 is 2. 6 over 2 is 3. 12 over 2 is 6. I already have those. Now each of those over 4. 1 over 4 is 1/4. Oops. 2 over 4 is 1/2. I already have that. 3 over 4. I don't have that one yet. 4 over 4 is 1. 6 over 4 is 3 over 2. And 12 over 4 is 3. I already have that. So I have all of those possible rational zeros. Let's go ahead and graph this and see if we can find one rational zero that we like. So let's go back to our calculator here. I don't have this one entered in. Whoops. So let's clear that out and let's enter this polynomial in. So 4x to the fourth plus 13x to the third minus 8x squared. Whoops, didn't get out of my exponent. Let's go back. Forgot to get out of my exponent. Okay, I need the 3 in there, right? Okay, now let's get, sorry about that. Minus 8x squared plus 13x minus 12. Okay, let me make sure I got that in there correctly. That looks good. Let's graph this and see what it looks like. Whoa, okay, that's interesting. Okay, so I'm seeing two real zeros, one right here and one right here. It looks like this one is going to be -4. Let me confirm that with my table. So I have a few values in here already. So yeah, so when x is -4, y is 0. And that appears to be the only integral value, the only integer. But that's useful. I can go ahead and use synthetic substitution with that. So from the graph, I have x equals a -4, which notice was one of my possible zeros. So I'm going to use that with synthetic substitution. So -4, and my coefficients 4, 13, -8, 13, and -12. Bring down the 4, -16, -3, 12, 4, -16, -3, and a remainder of 12, or 12 gives me a remainder of 0. Excellent. Now if you'll recall from the previous section, this is what we call a depressed polynomial. Depressed polynomial. In other words, I've done synthetic substitution, and basically what I've done is I've factored out an x plus 4, and this is the polynomial that's left. So this is going to represent 4x to the third minus 3x squared plus 4x minus 3. Now let's go back and look at our graph again, because I can't factor that. Well, maybe I could. I don't know if I can. I'm not going to try. I'm going to go back to my graph and see if I can figure out another rational zero, because I actually did have one there. So on my graph, I had this value right over here, which is definitely a 0. Let's see if that's a rational zero. So that's between 0 and 1. So from my list, what values did I have that were between 0 and 1? I had a 1/2, or 1/4, or 3/4. So from the graph, I have a rational zero at, and from my list of possible rational zeros, it could be 1/4, 1/2, or 3/4. So let's go back and look at the table. So it's looking like it's a little closer to 1, so it could be 3/4. So let's check that with the table. So if I put in 0.75, which is 3/4, I do get a y value of 0. So I have another rational 0 at x equals 3/4. Okay, so we're going to confirm that with the table. I have x equals 3/4 as another rational 0. Now what I'm going to do is use synthetic substitution on that depressed polynomial. On the result that I got last time I did it on my depressed polynomial. Okay, so 3/4, and then my coefficients of this polynomial right here are 4, -3, 4, and -3. Let's bring down the 4. It's going to give me a 3, 0, 0, 4, 3, and my remainder is 0. Okay, and that's great. That shows me that that is a 0. So this is going to be x squared plus 0x plus 4. Now I need to, since I'm trying to find all of my zeros, I need to set that equal to 0 and solve that. First, oh, I'm sorry, I forgot the 4 in front of the x squared. 4x to the squared plus 0x plus 4. First thing I'd like to do is take out a 4. And when I divide both sides by 4, I get x squared plus 1 equals 0. Give myself a little more room here. Solving that, let's move the x to the other side. And taking the square root of both sides. Plus or minus square root of -1, which is plus or minus I. So my 4 zeros, and it makes sense that I should have 4 zeros because it was an x to the 4th, were -4, 3/4, a positive I, and a negative I. And looking at the graph, that makes sense. I saw that it crossed in 2 places and didn't cross in 2 others. So in this section, we took a look at the rational zero theorem, which is very helpful for trying to find out what are some possible rational zeros. Sometimes it's very easy to look at a graph on your calculator and see that it's x equals -4. But if it's between two values, you want to know what pool of numbers you can pull from, often those fractions like we saw in this last example of using 3/4.